It's important. You guys go and watch it. It's very important. Collision questions you will get in exams. Okay. Now we're going to start with the new chapter, rotational motion. Okay. So for that, first you need to understand what is a rigid body. Okay. Rigid body means any body you take any object. Okay. So if I take 2 points A and B, and if I move it around, no matter in what direction I'm rotating or I'm moving, this distance between these two should not change. Okay. Let's say if it is R, then this should not change. It should be very rigid object. Okay. That we call rigid body. So we are going to study only rigid body dynamics. Okay. Rigid body dynamics. Okay, guys. Any doubt on this rigid body?
No, sir.
Yeah. So in simple, if I want to make it simple, kinematics or in kinematics or translational motion we call it, and rotational motion, they have some analogy. Okay. There we used to study displacement. Here we will study the angle. Okay. Here we used to study velocity. Here we will study angular velocity. There we used to study mass. Here we will use to study moment of inertia. Here we used to study force. Here we will study about torque. Here we used to study acceleration. Here we will study angular acceleration. Okay. So that's it. If you know these things, then the game is over. So translational motion only we study about these things. Okay. In rotational motion, we study only these things. What if a body is rotating also, moving also? We will call it as combined translational and rotational motion, CTRM. This means combined translational and rotational motion. So if this kind of questions come, you divide it in translation and rotation, then combine. That's it. Xavier, you listen this lecture carefully. For you, it will be very useful later.
Yes, sir.
Yeah, note it down. Each, what is theta, what is omega, what is I, you write their names. I'll wait for 2 minutes.
Sir, copy the table.
Write what is theta, what is omega. Their name you write.
Sir, could you state their names again?
This side you know, right? Kinematics table.
Yes, sir.
This side you write angular displacement, angular velocity, then moment of inertia, torque, angular acceleration.
Sir, I is moment of inertia, right?
Yes.
Okay, sir.
Done, sir.
Xavier, you done?
Yes, sir. So just the last one I did not get.
Yeah, write it.
Sir, are you presenting your screen?
Yes. You are not able to see?
No, sir.
1 second. Samhita is joined, I guess. So, Samhita, when is your exam?
8th.
Yeah, discuss with Shreyuta. How was it? Yeah, see. Done, right, everyone? Samhita written?
Yes, sir.
Okay, let me go ahead.
So done.
So, we have S, V, A, and then we have, what do we have? F. Okay. Then here we have theta, omega, alpha, and tau. So I will write here V is equal to ds by dt. Okay. A is equal to dv by dt. Okay. And you know that m will be replaced by I. F is equal to ma. Can you guys write same here for rotational variables? 2 minutes. Write quickly. One by one, each of you have to tell me one formula. Done, guys?
Yes, sir.
Yeah. Samhita, tell me what is the first formula you have written?
So, angular velocity omega is equals to d theta by dt.
Okay, Shreyata, you tell one.
Angular acceleration is d omega by dt.
Okay, Xavier, you tell me.
So for work done, it is uh, rho by theta. Tau by theta.
So omega is equal to d theta by dt, right? So what we did,
Yes.
we replaced s by theta. That's it, right? This is the replacement you have to do. So alpha is equal to d omega by dt. So F is nothing but torque here. Mass will be I, A will be alpha. What are you saying, Xavier?
No, sir, I mistook that for work done. W.
What? Okay, everyone written this. Let's go ahead. Devian, listen carefully, man. S is equal to ut plus half at square. V is equal to u plus at. V square is equal to u square plus 2as. Okay. These three formulas you write in rotational format. And consider, okay, initial angular velocity as omega naught, final as omega. Write down. This means u is omega naught, v is omega. Samhita, why did you not join yesterday?
So I wasn't feeling well.
Hmm. Now you are feeling well.
No,
Here I am not telling you to do any work, right? You should just sit and listen. Please don't miss the class. Every class has its value. You watched yesterday's lecture, Samhita?
not yet. So I'll watch after this lecture.
Okay. Zivian, you also didn't join yesterday.
Yes, sir.
What happened?
So I was in, out, so I couldn't join.
Written, guys?
Yes, sir.
Yeah. Zivian, I'll start from you. Tell me what is the equation you have written. Any one equation you tell me. Quickly. Zivian, what happened?
Yes, sir. So I said, think
Tell.
omega is equal to d theta by dt, which is equal to theta naught. The
Omega is equal.
angular velocity, which is
Man,
equal to theta naught.
what I'm asking you is just give me these three equations in rotational format. I don't know. You don't listen class at all. Yes means what? Theta is equal to omega. U means omega naught. I told you everything is there. You don't just need to put, and you are not doing that. In place of A, you need to put alpha. For this, omega is equal to omega naught plus alpha t. For this, omega square is equal to omega naught square plus 2 alpha theta. Here also you can avoid equations if you understand alpha properly. Axel, I told you, right, how to solve without using these equations. Same analogy you can use here also. Okay. Write down these. Savian, listen carefully. Huh? I feel like you are just
Yes,
here, your mind is somewhere else. Shall I go ahead, guys?
Yes, sir.
Okay then. So only one thing we have to study about is moment of inertia. What is it, right? So moment of inertia is given by I is equal to mr square. Okay. So for example, let us say there is a particle of mass m which is rotating about this axis, okay, which is sitting at a distance r. Okay. So you have to first define about which axis it is rotating. Okay. So omega tells you with what velocity it is rotating. Okay. So if it is a mass m and a perpendicular distance is r, then the moment of inertia is given by mr square. Okay. So there are standard moment of inertias you need to remember. So one is the rod. Okay. The standard one is if I have a rod of mass m, let us make it like chart on next page. Okay. First is a rod. Okay. So if there is a solid rod like this of mass m and length l, about its center, okay, about its center, the moment of inertia is given by ml square by 12. I'll ask this in tomorrow's class. Okay, ml square by 12.
Sir, could you repeat once more?
ml square by 12. Okay, then we have a ring about its center. Okay, axis passing through its center. It is rotating with omega. The moment of inertia will be mr square. Okay, about center. For a disc, okay, this was ring. Okay, this is rod. This is disc. Disc means solid, right? This is solid. So about its center, it is I is equal to mr square by 2, where r is its radius. Okay, guys. Then, so if they ask about diameter, no, this is about center for ring. If they ask about diameter, you just need to make half. Everywhere you need to half. For this also you make half. If they ask about diameter, okay, understood? Then comes a sphere. Sphere, there is hollow and solid. For hollow sphere, about its center, the moment of inertia is given by 2 by 3 mr square. Okay. For a solid sphere, the moment of inertia is given by 2 by 5 mr square. Okay. Any doubt?
No, sir.
Yeah, please note it down. Shall I go ahead?
Yes, sir.
Yes, sir.
There is a theorem, parallel axis theorem. What it says is like for any object, forget about a rod. For any object, okay, Let us say this is the center of mass or center. If you know the moment of inertia about that is, let's say, I. Okay. And I want to know what is the moment of inertia about this axis. Let's say at A. What is this I dash? Okay. So for that, these two should be parallel and you just find what is this distance. Let's say it is X. Okay. Then I dash is given as I plus you add a mx square where m is the mass of the body. Okay. Understood?
Yes, sir.
Okay, note it down. We'll do it some examples. So for example, for rod, okay, if I ask you what is the moment of inertia about this end axis. So what you will do, you know this about center, right? What is the moment of inertia, you know. So what will be this distance from center? It is L by 2, correct? Now my x is equal to L by 2. So I dash is equal to I plus mass is m, length is L by 2 whole square. Understood? And I you already know that is ml square by 12 plus ml square by 4. If you solve, you will get ml square by 3. Simple, right?
Yes, sir.
Parallel axis questions only they ask mostly. So shall we do some questions?
Yes, sir.
Okay, so just give me a second. Okay, so this okay, see this question. Are you guys able to see?
Yes, sir.
So what he's saying is, one more thing you have to know that the relation between V and omega is R omega. Okay. Similarly, A and alpha is R alpha. These two formulas, I hope you know. Still, I'm telling you, just note this out. Now, what he's saying is there is a disk. Okay. This is height h. There is a disk which is moving with a velocity v. Okay. If it is moving with velocity v means it is the velocity of center of mass. Okay. Now they are saying that it starts moving up an inclined plane and it reaches some height. We want to find what is the maximum height. So guys, tell me, once it reaches the top, will it stop or not? It will stop, right? Finally, its velocity becomes 0 and omega equal to 0. You know, when something reaches maximum height, its velocity becomes 0. So that means we know that from work energy theorem, the work done is equal to change in kinetic energy. Correct? Work
Yes,
done
sir.
is equal to change in kinetic energy. So work is done. How much? It is done mgh. Only gravity has done work, right? Nothing else has done the work. Only gravity is done the work. So mgh is equal to but mg is down, it is moving up, displacement is up, mg is down, you have to put a minus sign. K final minus K initial. What is finally kinetic energy? 0 minus. What is initial kinetic energy? Half mv square. Plus, you have to add rotational kinetic energy also. So, because it is rolling also, right? So, half, what m will be replaced by I, correct? And v will be replaced by omega. So, this minus mgh is equal to this. Minus minus got cancelled out, m got cancelled out. So m is let me keep it like that. Mgh is equal to 1 by 2 mv square plus here half for a disk. What is the moment of inertia? I told mr square by 2, correct? And omega can be written as, from here, can you tell me what will be omega? V by R. So let us write it. V square by R square. R square got cancelled. M got cancelled out. So from here, what we are getting is, I will write here, we are getting GH is equal to V square by 2 plus V square by 4. Correct, guys? Am I doing correct? Yes. So from here, what will be H? Solve this. LCM is 4. 3v square divided by g. This will be your answer. 3v square by 4g. Simple, right? Everything is already taught to you. Understood, everyone? This
Yes,
is
sir.
translational kinetic energy. This is rotational kinetic energy. So when rotation comes, you have to consider this energy also. And shortcut, I told you, m replaced by I, v replaced by omega. Okay? So it will be, so only the translation kinetic energy of this changes into gravitational potential energy, and rotational kinetic energy remains unchanged as there is no friction. So half m square is equal to mgh, h is equal to v square by 2g. Why he did not consider rotational kinetic energy? Okay, so here see what one word they have used here in this question. It moves up inclined smooth surface, rolling or without slipping. Without slipping means the omega will not change. Even if it reaches the top, it will not stop rotating. Okay, it is still rotating, correct? Omega won't be 0. So initially, whatever the rotational kinetic energy half I omega square it had, same it has on the top also. So there is no change. Okay, we did one mistake here. See guys, we did one mistake. Initial kinetic energy is this. Finally, the omega I won't be 0. To move up, it needs V, right? So, but it can still rotate in the opposite direction. So omega is there finally. So finally, you have to write half I omega square. This will get cancelled out. Only mgh is equal to half mv square will remain. So you please note down that word without slipping means there is no change in rotational kinetic energy. Understood?
Yes, sir.
So angular momentum I haven't taught, I will teach. Heavy iron bar of weight is having its end on ground and other end shoulder of a man. This we already discussed. Disc rolling without slipping on a surface. The radius of disc is r, t equal to 0. The topmost point on the disc is a. The figure, when the disc completes half of its rotation, the displacement of point A from its initial position is. Can you guys try this question? There is a disc which is rolling without slipping on a surface. Okay. The radius of the disc is r. So at t equal to 0, A was at the top, right? What they are saying is point on the disc is A as shown in the figure. When disc completes half of its rotation, they are asking what is the displacement of A. So It's such questions they ask, okay, very common. So you draw first this, okay. This is your point A, correct? So when it start rotating, so this will, like this is rotating like this. So now when it completes half the rotation, where will this point A reach? This B has to go up, right? A will come down, correct? So if you draw it again, so when it completes half rotation, where A will reach? Where A will reach here, correct? And horizontally, how much distance it has traveled? This length, right? Pi r by 2. Now I want displacement. Just join this initial to final position. You need to calculate this. This is the perpendicular triangle. You know this is 2r, correct? This is pi r by 2. Use Pythagoras theorem. Under root 4r square plus pi square r square by 4. This will be the displacement. Understood?
Yes,
Everyone
sir.
understood? Yeah. So it will be r into pi square plus 4. See? Simple as that. Torque is given if the force acting on particular position after this. I haven't taught it, I'll teach. This I'll teach later. So tomorrow I will cover everything and I will finish this chapter. See, a ball is spun with angular velocity, angular acceleration alpha this much, where t is in second and alpha is in radian per second square. The ball has initially 10, okay? Angle omega naught is 10 and angular position theta is 4. The most appropriate expression for the angular position of the ball is. So guys, see what they have given. Alpha is equal to 6t square minus 2t. Alpha is equal to 6t square minus 2t, and they are saying initial omega naught is 10, initial theta naught is 4. So we know that alpha can be written as d omega by dt, correct? So from here, d omega is equal to alpha dt, correct? Integrate on both sides from initial to final. This from t is equal to 0 to t. From here, what will be the integration of d omega? It is omega. So omega minus omega naught is equal to alpha is 6t square minus 2t dt from 0 to t. So now you put t, integrate this 6 into t cube by 3 minus 2 into t square by 2. Put the limit, 3 ones are 3 twos are 2 cancelled out. So it is t cube minus t square. This is omega minus omega naught is 10. So omega is equal to t cube minus t square plus 10. Understood till here?
Yes, sir.
Okay. How much? T cube minus t square plus 10. So omega is equal to t cube minus t square plus 10. Omega can be written as d theta by dt, which is equal to t cube minus t square plus 10. D theta is equal to t cube minus t square plus 10 into dt. Integrate. Initial to final. Okay. 0 to t. So d theta means theta minus theta naught is equal to integrate t power 4 by 4 minus t cube by 3 plus 10t. Okay. So theta naught is 4. So theta is equal to t to the power 4 by 4 minus t cube by 3 plus 10t plus 4. This should be the answer. Understood, guys?
Yes, sir.
Okay. So should be t power 4 by 4 something plus 4. There should be plus 4. So yeah. So there is only one option. So that is option B. Same way we have done, right? So I think that's enough for today. It's 6:40 already. So you now try to attend the questions based on the concepts I taught only for today. Tomorrow we'll finish this chapter and we'll go for class 12th. Okay?
Okay, sir.
Okay. All right. Thank you.
Thank you, sir.